So hey guys, welcome back to my channel. It's me Elma, and for today's video, we are going to discuss the laboratory determination of California bearing ratio. So first, the standard IS 2720 Part 16 1979 definition. California bearing ratio is the ratio of a force per unit area required to penetrate in the soil mass with a circular plunger of 50 mm diameter at the rate of 1.25 mm per minute. So the apparatus molds to 2250 cc capacity with the base plate, stair rod, and wing nut conforming to 4.1, 4.3, and 4.4 of IS 9669-1980. Collar confirming to 4.2 of IS 9699-1980. Spacer disc confirming to 4.4 of IS 9669-1980. Metal rammer confirming to IS 9189 1979. Expansion measuring apparatus with the adjustable system, perforated plates, tripod confirming, and two weights confirming to 4.4 of IS 9669-1980. Loading machine having a capacity of at least 5,000 kg and equipped with a movable head or base that travels at a uniform rate of 1.2 mm per minute for use in forcing the penetration plunger into the specimen. Penetration plunger confirming to 4.4 of IS 9669-1980. Dial gauge 2 numbers reading to 0.01 mm. IS sieve 37.50 or 22.50 or 19 mm and 4.75 mm. Miscellaneous apparatus such as mixing bowl, straight edge scales, soaking tank, drying oven, filter paper, dishes, and calibrated measuring jar. So here the procedure. First, there are two types of methods in compacting soil specimen in the CBR molds: the static compaction method and the dynamic compaction method. The materials in the above two methods shall pass 19 mm sieve for the fine-grained soils and 37.50 mm sieve for coarse materials up to 37.50 mm. Replace the material retained on 19 mm sieve by an equal amount of material passing 19 mm sieve and retained on 4.75 mm sieve. Replace the material retained on 37.50 mm sieve by an equal amount of material passing 37.5 mm sieve and retained on 4.74 mm sieve. Static compaction. In this method, calculate the mass of wet soil and required moisture content to a given desired density when compacted in a standard test mold as given below. Volume of 2,250 cc weight of dry soil to 250 times mmd. Weight of wet soil is equals to 1 plus m over 100 times w. Weight of water is equal to weight of wet soil minus weight of dry soil. Optimum moisture content obtained from the laboratory compaction test. Take a concentrate soil sample of calculated weight and thoroughly mix with water OMC as obtained from the above equation. Record the empty weight Record the empty weight of the mold with base plate with extension collar removed. M1. Place the correct mass of wet soil in the mold in 5 layers. Gently compact each layer with a spacer disc. Place a filter paper on the top of the soil, following by a 5 cm spacer disc. Compact the mold by pressing it in between the platens of the compression testing machine until the drop of the spacer disc comes flush with the top of the mold. Held the load for about 30 seconds, then release. In some soil types where a certain amount of rebound occurs, it may be necessary to reapply load to force the placer disc slightly below the top of the mold so that on rebound the right volume is obtained. Remove the mold from the compression testing machine. Remove the spacer disc and weight the mold with compacted soil M2. Replace the extension collar of the mold. Prepare 2 or more specimens the same procedure as described above. Dynamic compaction. Take representation sample of soil weighing approximate 6 kg and mix thoroughly at OMC. Record the empty weight of the mold with base plate with extension collar removed M1. Replace extension collar removed. Insert a spacer disc over the base plate and place a coarse filter paper on top of the spacer disc. Place the mold on a solid base such as concrete floor or plinth and compact the wet soil into the mold in 5 layers of approximately equal mass, each layer being given 56 blows with 4.90 kg hammer quality distributed and dropped from a height of 450 mm above the soil. The amount of soil used shall be sufficient to fill the mold, leaving not more than about 6 mm to be struck off when the extension collar is removed. Remove the extension collar and carefully level the compaction soil at the top of the mold by means of straight edge. Remove the spacer disc by inverting the mold and weight the mold with compaction soil. Place a filter paper between the base plate and inverted mold. Replace the extension collar of the mold. Prepare 2 more specimens the same procedure as described above. In both cases of compaction, if the sample is to be soaked, take a representative sample of a material at the beginning of the compaction, another sample of remaining material after compaction for the determination of moisture content. Each sample shall weight not less than 100 grams for fine-grained soil and not less than 500 for granular soil. Place the adjustable stem and perforated plate on the compacted soil specimen in the mold. Place the weight to produce a surcharge equal to the weight of the base materials and pavement to the nearest 2.5 kg on the perforated plate. Immerse the whole mold and weights in a tank of water, allowing free access to the water top and the bottom of specimen. Test for swelling. This test is optional and may be omitted as partners. Determine the initial height of specimen in mm. Mount the expansion measuring device along with the tripod on the edge of the mold and record the initial dial gauge reading. Keep this set up as such and distribute 96 down to a day against the time of reading. Maintain a constant water level throughout the period of soaking. Note the final reading of the dial gauge at the end of soaking period. So, expansion ratio dF minus ds over h times 100, where ds is the initial gauge reading in mm and dF is the final gauge and h is the initial height of specimen. So, here the picture of this testing of the CBR. The penetration test. After 96 hours of soaking, take out the specimen from the water and remove the extension collar, perforated disc, surcharge weights, and filter paper. So here you can see the calculation of CBR from a penetration curve. So here the load versus penetration curve. The caliper bearing ratio is equal to PT times CV CF over PS times 100, where PT is the corrected unit test load corresponding to the chosen penetration from load penetration curve. The PS is the total standard load for the same depth of penetration, which can be taken from the table below. CF is the proving ring corrector factor. So this is the standard load specified penetration. So there are the report the CBR bar to the nearest second decimal. So yeah, the precautions: clean the holes of the base. So here is the California bearing ratio test data sheet. So as you can see, it's from Punjab State Road Sector Project PWD B&R. So that's all. I hope you guys learned something or enjoyed the video. If you do, please click the top. So don't forget to give this video a thumbs up. Click the subscribe button and the bell button right beside it so that you'll get notified whenever I upload a new video. That's all for today. Bye!